Now, we've already heard about many parameters that influence the MR image. T1, T2, proton density, pulse sequences, TR and TE. But there are more. For example, contrast media and flow. The fact that flow influences the MR signal has been known for a long time. The first experiments on this subject were carried out more than 40 years ago. Interestingly, this phenomenon was used to measure flow in the fuel pipes of satellite rockets, without having to put any obstruction into the flow lines.
3, 2, 1, 0.
The subject of how flow influences the MR signal is rather complex and difficult, but let us at least get some idea about it. In this figure, we have a body section through which a vessel is crossing. When we send in our first 90-degree pulse, all the protons in the cross-section are influenced by the radio wave. After we turn the RF pulse off, we listen into the section and record a signal. At this time, all the original blood in our vessel may have left the slice being examined. So there is no signal coming out of the vessel. It appears black in the image. This phenomenon is called flow-void phenomenon. This is not the only way in which flow may influence the image. There may be all kinds of things. For example, flow-related enhancement. This illustration shows a blood vessel going through a slice which is being examined. The figure represents the situation before the 90-degree pulse. Immediately after the pulse, longitudinal magnetization is tilted 90 degrees. If we wait some more time before we send in a second 90-degree pulse, protons will have undergone some relaxation. And there is some longitudinal magnetization again, as shown by the arrows pointing back up. The protons in the blood vessel, however, have left the slice and been replaced by protons that still have all of their longitudinal magnetization. If we send in a second 90-degree pulse now, there will be more signal coming from the vessel than from its surroundings, because there is more longitudinal magnetization at this time. The whole subject with signal strength and flow effects is actually much more complicated. For example, when you do multi-slice imaging, in other words, taking images of more than one slice at the same time, we'll hear about this technique later, the signal also depends on the direction of the flow.